Okay, for tonight's homework, again, I'm going to have you copy all the work. It's up to you if you want to write the words or not, but all the work in the numbers and these dots. And the 5 words to make sure that I know that you listen to me and not only watch this and copy, but listen to what I'm saying. All right, this first one. This has you add the number of dots up. That's 2 of them. 5 dots here, 8. And that's all I need to know. This is going up by 3. Makes it an arithmetic sequence. Adding by 3, straight line, arithmetic. Subtracting by 3 to the left gives me the 0 term, which is 2 minus 3, which is -1. And then writing that arithmetic equation using the f of x form equals always the common difference number or slope times x plus the function at the 0 term or the y-intercept, the 0 term. So again, the main part of this module test coming up is, can you write a basic equation to model that data? Put the common difference number there in front of x, put the y-intercept there for f of 0. So this equation is f of x equals 3x minus 1. So I would do that first. Get your equation first. And then I could see which of these is good or bad. This one matches exactly. Same slope, same y-intercept, exactly. This one is this equation in recursive form. Every term before it, keep adding 3. That matches that common difference number. Recursive form, perfect, matches this data. Recursive. These other two are a little trickier. This one doesn't look the same, but when I take this 3 and distribute it times x and -1, what it does is give me 2 plus 3x minus that 3. And then that 2 and that -3 from multiplying 3 times -1, that's how I get the -3, combines to give me -1. So that one is equivalent. Doesn't look the same, but it is. These two are exactly equal. These two equivalent, but they're still equal. This one right here is no good because it's got a different number in front of x right away than 3. It's got a different y-intercept number right away. That one is the only bad one of the bunch. All right, design 0, that is f of the 0 term. So the function at the 0 term, f of 0, equals -1. If I plug in 0 in here and that goes away, that gives me -1. To find how many squares in step 25, I'm going to use this equation up here. I'm going to use that 3x minus 1. And that, when I evaluate that, I'm going to plug in 25, not 2.5. 25 will be the same on the test. The function at 25 equals 3 times 25 right here. Close that parenthesis. Minus 1. That gives me 75 minus 1. So the function at the 25th term is 74. Again, there's going to be a problem just like that Friday. Make sure you know how to do it. All right, the next one. The table one definitely is more difficult. The first word is multiply. Multiply. For this one, they want the equation in slope-intercept form. So make sure you're writing that with a y and not f of x. Slope-intercept form, y equals mx plus b. For my y values, going down by 1. My x values for this problem, going up by 5, going up by 5. So if I put these two numbers together to get my slope, remember slope is rise over run, the change in y over the change in x. I get that by finding how much my y is changing. This represents change in y. divided by the change in x. If I put those numbers in, -1 up on top, that 5, that run number on the bottom, it gives me a slope of -1 over 5, which means if I was to graph it, every time I go over 5 boxes to the right, down 1, 5 right, down 1, 5 right, down 1, negative slope straight line. That is half my answer. That's the number that's going to go in front of m. So that is my slope, mx plus b I'm looking for. So I'm going to replace this number right in here for m for my slope. Make sure I include the negative. Always include the negative there. Y equals -1/5 x. And then I'm going to try to show you how to find this b term by expanding on this table here, because between here and -3, I want you to see what's going on. Between this 2 and 7 going down and over here, I want to see and show you what's going on in these little spaces that are not being shown. So my slope, or my rate of change now every time going down one term, is going down by 1/5, going down by 1/5, subtracting by 1/5, subtracting by 1/5. If I was to go up, adding 1/5, adding 1/5, plus 1/5, plus another 1/5, plus one more 1/5. So here I go, going up the table. Again, trying to find these values in here. 7 plus 1/5 is 7 and 1/5. 7 and 1/5 plus 1 more fifth, 7 and 2 of those fifths. That's the y-intercept. Going up one more, 7 and 3/5. Going up one more, 7 and 4/5. And up to here, 7 and 5/5 is 8. That's 7 plus 1, that's 8. It's not 7 times 1, 7 plus 1. Going down, 6 and 4/5, 6 and 3/5, 6 and 2/5, and then 6 and 1/5. 6 is the same as 6 and 0/5. Right here again, this is 6 and 5/5. If you want to think of it that way, 6 and 5/5. The 5/5 goes down to 4/5 if you want to write it that way. But that is my y-intercept number. This green term, 7 and 2/5. I'm going to take that number and put it right in here for b to finish up this equation. So this gives me -1/5 x plus 7 and 2/5. If I was to write that as a decimal, that would be -0.2 x plus 7.4. If I was to write that as decimals. Again, make sure you're writing y and not f of x for this problem on Friday. Y, not f of x. The second word is. Is the second word. All right, here we go. This one is geometric. Dividing by 3. I could see this dividing by 3 easier right here. But remember, we don't show dividing by 3. We show that as timesing by the reciprocal of 3. Timesing by 1/3. Timesing by 1/3. Timesing by 1/3. If I was to go to the left, remember this is the first term. Second, third tells you it's the first term. Again, if none of this was here, this is assumed that's the first term always. If I go back to the 0 term, the opposite of timesing by 1/3 is timesing by 3. So that 0 term, 135 times 3, that gives me a big number, which is 405. This is definitely geometric. Any function that's timesing, geometric, multiply. That first one was adding, arithmetic. Straight line adding, these multiply ones, curved line. The recursive function, f of x equals f of x minus 1 times 1/5. The third word is geometric. Geometric. All right, that is the recursive function. Notice nothing plugged in there for x in its generic form. The two explicits, I'm going to show you how to use the first term, 405, times that common ratio 1/3 raised to the x power if you use that one. Or f of x equals the first term, which is 135, times 1/5. Ooh, did I use 1/5? Oh my goodness, really? Alright, so I want you to make those changes on there. I see a mistake. This is 1/3 right there, and this is 1/3. Please change that. This should not be 1/5. This should be 405 times 1/5 to the x power, or 135 times 1/3 to the x minus 1 power. Okay, so I definitely want you to fix those mistakes I made on this problem. I want you to make sure you replace this with 1/3. I want you to know that the two equations that you're going to use are 405, the zero term, times that common ratio to the x power, or shifting over 1 to the right, 135 times 1/3 to the x minus 1 power. I'm going to use this second one to evaluate it for the 10th term. So the function at 10 is 135 times 1/3 to the 10 minus 1 power. Gives me 135 times 1/3 to the 9th. The fourth word is arithmetic. Arithmetic. This work over here for 1/3 to the 9th, I wanted to show you over here as 1/3 to the 9th power. You're timesing 9 of those 1/3. Timesing all the way across gives you 1. But then on my calculator, I'm going to calculate 3 to the 9th power. Gives me 19,683. When I replace that with what that really is, I still have the 135 times 1 over 19,683. I could time straight across and leave it. Or I could reduce it using the fraction button on my calculator down to 5/729. Might not want to write that as a decimal. Be kind of difficult. 0.00685. So again, I would leave it in fractional form, either reduced or not reduced. The fifth word is add subtract. The fifth word is add subtract. Alright, so tomorrow turn in this work with the 5 words. It will help you practice. For my Math 1 Honors classes, hopefully this tutorial video helped you a little bit. Good luck.